Okay, so we're going to review 9.4, 9.5. 9.4 was parametric equations. So that we got 3 different types of questions in 9.4. This was the first. Graph giving your equations. Remember, parametric has the t in it. That's how they're different. So if you were given the range of -2 to +2, then you're going to take and plug those values in for t. So -2, -1, 0, 1, and 2. And you're going to plug it into the x, and then you're going to plug it into the y, and then put those together to get your x, y coordinates. So if I plug in -2 into the x, I get 2 times -2 plus 3, -4 plus 3, which is -1. Then I go 2 times -1 plus 3, which is -2 plus 3, or 1. Then I go 2 times 0 plus 3, which is 0 plus 3, or 3. 2 times 1 plus 3, 2 plus 3, which is 5. 2 times 2 plus 3, which is 4 plus 3, or 7. And then I repeat that process for y. So t squared minus 1 would be -1 squared minus 1, or 1 minus 1, which is 0. Oh, sorry, that's -1. -2 squared minus 1 would be 4. Minus 1, which would be 3. Then -1 would be 0. Then 0 squared minus 1, -1. 1 squared minus 1, 0. 2 squared minus 1, 3. So then it's the x, y combination. So -1, 3, 1, 0, 3, -1, 5, 0, 7, 3. And then I'm going to plot those points. And then connect your points, and then establish your direction. So you want to move towards the largest t value, away from the smallest and towards the largest. So my arrows are moving in that direction. Remember that the parametric equations should have direction when you're graphing them. And then I can easily check this using a graphing calculator. I just have to make sure that my mode is in parametric so that I get the t. I'll get an x and a y, and then I'll get the variable being t. And if I want it to look exactly like my graph, I want to restrict my window to be that -2 to +2. So again, the first thing you want to do is make sure your mode is in parametric. I'm going back to parametric because we were in polar before we left. And then when I go to the y equals, I have 2 equations. So I would do 2t plus 3 for the first one. And then my second one, I'm not recording this. I put myself in parametric, and then I go to the y equals, and I'm typing this in. T squared minus 1. And then when I graph it, I'm going to get the curve that could be similar to what I have. If I want an exact thing, I'm going to go to the window, and I'm going to change my T-min to match my minimum, which is the same, which is 2. And then my maximum to be 2. And then go back to my graph, and now it should look just like my graph. But again, this is like the one time you're smarter than your calculator, right? Because your calculator doesn't know the direction of the arrows to put. You got to make sure you add those on. So your test will be part calc, part not calc. This would be on the not calc part because I want you to be able to graph it. Okay, but feel free to be checking it with your calculator so you're familiar with it. Questions on that one? Okay, second kind of question was eliminating the parameter. So to eliminate the parameter, you would get rid of t. So if I took these equations, y equals x squared plus 3 and x equals t, I want to get rid Oh, not, I'm sorry. I'm going to eliminate the parameter on this example. The other one's already eliminated. So I would take one of those equations and solve it for t. In the first one, I'd have to subtract and then divide. In the bottom one, I'd have to square root it. So honestly, it's probably easier to do the first one. So if I said x equals 2t plus 3, and I want to solve that for t, I'd get x minus 3 equals 2t, and t equals x minus 3 all over 2. And then I would take that one and plug it into the other equation. Oh, no, they're both squared. And now you've eliminated your parameter. So again, you would get rid of the t by solving one of the equations for t and taking it and plugging it back into the other equation so that your answer doesn't have a t value in it. If I wanted you to graph that, you'd have to keep going. Like I'd have to square it. That one gets kind of nasty to graph. You probably wouldn't graph something like that. But if you did, it should look like your original graph, except that there would be arrows at the end because it wouldn't have a restriction. Questions on either of those types? Okay, third type in 9.4 was if you had two equations, one being rectangular, so this is rectangular because there's no t in it. This is parametric because there's a t in it. And I want to get two parametric equations. I'm going to take the one that is solved for t, and I'm going to plug it in the place of the other one. So I'd get y equals t squared plus 3. And then my answer is the two equations, one x equals and one y equals, that both have a t in them. So 3 different types of problems: graphing from the beginning, making sure we put the arrows on it, eliminating the parameter where we solve one for t and plug it back in to get rid of the other one, and then the third kind where you're given two equations, one that's rectangular, one that's not, and you want to make them into parametric. Questions on anything in 9.4? All right, then came 9.5, which was polar coordinates. This is obviously super important because if you don't know how to graph a point on a polar graph, you're certainly not going to be able to put together an equation on a polar graph, which is what we're going to do tomorrow. So you want to make sure that you're really comfortable plotting these polar coordinates. So the very first thing was literally just plotting them. So if this is a test, you'd be given a polar coordinate grid, something like what's there, and then you'd be asked to graph them. If it's in polar, then it's r theta, r being the radius, theta being the angle. So if I want to graph that first one, then the first thing I'm going to do is locate theta. So pi over 6 is here. And then on this, I'm going to go to the second ring, which is here, and this would be 2 pi over 6. The answer there is just the coordinate point, not the line that gets you there. The line that gets you there is how you locate it, but the answer itself is just a coordinate point. The next one is negative 2 pi over 6. So remember, when the radius is negative, I would still start in the same location. So this is still pi over 6. But instead of working in that direction, I would locate the opposite ray, which is actually along this side, and move along that one. So it's still 2, but it's 2 on the opposite ray. This would be negative 2, pi over 6. And then let's say you had something like 2 negative 7 pi over 6. So if the angle is negative, I would move the other way, right? I'm going clockwise. So 7 pi over 6 is just big. It'd be 1 and 1/6 pi. So I'd go past my 1 pi to the first pi over 6, which is here. And then that's a positive 2, so I go to the second rung. To negative 7 pi over 6. So the negative on the angle just moves clockwise instead of counterclockwise. The negative on the radius moves away from the initial angle in the opposite direction. Any questions on those? Okay, you were also asked to find additional coordinate points that would be the same point on your circle. And there's 2 options here. One is keeping R the same, but then adding or subtracting even multiples of pi. So if I wanted to find another coordinate point of 2 and pi over 6, I could keep 2 the same, but then I would take pi over 6 and add or subtract 2 pi or 4 pi or 6 pi, whatever's going to get me in the range that they give you. And then my other option is if I start with r theta, change the sign to negative r, add and subtract odd multiples. Of pi. So if I wanted that, I would change the 2 to negative 2, and I would take pi over 6 and add and subtract pi, or 3 pi, or 5 pi, or 7 pi. That, so usually, well, every time you've done it, I give you some sort of range. Like, give me 2 other representations between negative 2 pi and positive 2 pi, or 0 and 2 pi, let's say, right? So if I said between 0 and 2 pi, and you tried to do it with this first coordinate point, you would take 2, leave it alone, let's try the first one, add 2 pi, it's too big, subtract 2 pi, it's too small. So then your other option is change the sign on 2, it would be negative 2, then take pi over 6 and add pi, now it's 7 pi over 6, that falls between the 0 and 2 pi range. So you're going to be forced to do both. The question is like, what's your range? It's either 0 to 2 pi, or it's negative 2 pi to 2 pi. I could ask you for 2 other representations, or 1 other, or 3 other, that kind of thing. But no matter what, when you do this additional points, if you plotted all your points, it should be the same point. Questions on additional points? So first thing we did was find the actual point, locate it, graph it. Then we found additional points, which is, again, keep the r, add and subtract even multiples of pi, change the r's sign, add and subtract odd multiples of pi. And then we converted from polar to rectangular and rectangular to polar. So if my initial point is in polar, it'd be in r theta format. Then I got to find the x and the y. And I would get the x by doing r times the cosine of theta. And I would get the y by doing r times the sine of theta. And it should make sense because cosine is x and sine is y. And then your answer will be in an x, y coordinate format. And then the other is getting from rectangular to polar. So if I gave you a coordinate point in x, y format, then you're going to find theta by saying the tangent of theta equals y over x. And then you'll do the inverse tangent to find theta. So without a calculator, you only have 5 options. Tangent can only be 0, pi root 3 over 3, 1, root 3, or undefined. Those are your only options for tangent if I don't give you the calculator on this portion, which you're not going to get the calculator on this portion, right? If it wasn't, like if I gave you something like the tangent of theta is 3 over 2, that would be on a part where you have your calculator. So you would do inverse tangent 3 pi over 2, or 3 over 2. The catch there is it's got to be in radians because all this stuff's in radians. But remember when you're finding, like, let's say it's the tangent of theta. Let's just say it's root 3. So I'd be saying, what is the angle if the tangent is root 3? And remember, for that option, you have 2 answers. For every single tangent option, you've got 2 answers on your unit circle that work. And that's going to be based on your initial point. So if my initial point was 1 and root 3, then I know this is in the first quadrant, which means I would pick theta to be pi over 3. The other way that could happen is if this is -1 and negative root 3, that would still give me a tangent of root 3. This time I would know to pick 4 pi over 3 because I know if it's negative and negative, it's in the third quadrant. So remember, with tangent, there's always 2 answers, and you got to base it on where your initial coordinate point would lay. And then the second part here would be to find r. R squared equals x squared plus y squared. And your answer here is going to be in r theta format. Questions on 9.4 or 9.5? So this is that first one. You're sketching the curve. It gave you -2 to 3. You need to plug those values in. And then you got some fractions. This time you just have to approximate where they're at. Obviously 6 over 5 is just past 1. And then your arrows point away from the smallest t towards the largest t. So this time they're going from right to left. Questions on this one? Okay, second one said write each pair of parametric equations in rectangular form by eliminating the parameter. So you're trying to get rid of t. So you can take y equals t and plug the y in the place of the t, and you can get this equation or this equation, doesn't matter which one, x equals negative y squared over 3 or negative 3x equals y squared. If I had asked you to approximate the graph, remember this time it's an approximation, you don't know where it stops. This would be a parabola that's pointing to the left because it's a y squared and a negative 4p. So you would have had a point at 0, 0, and then point your arrows to the left-hand side. This time you don't have direction, so you don't have the arrows moving along it, okay? Just make sure that you'd be able to approximate that graph. The third one said use the parameter to write the rectangular equation as a pair of parametric equations. So this time only one had the t, you had to put the t back into the other one. So because t equals y, I'm taking y and replacing it with the t, and I would have gotten x equals t squared over 6. This is a pair of parametric equations, so you need both the x equals and the y equals as your answer. X equals t squared over 6 and y equals t. Then 9.5 started with the polar. So you're graphing 3 and 11 pi over 6, which would have been in the fourth quadrant on the third ring. And then it asks you to find 3 additional polar representations from -2 pi to +2 pi. So the first one, I would have taken the 3 and kept it as 3, added 2 pi, it would have been too big, subtract 2 pi, I get negative pi over 6. And then I have to change the r to be negative, add and subtract odd multiples of pi, which is 5 pi over 6 and negative 7 pi over 6. Then it said find the rectangular coordinates for the point. So this is 3 times the cosine of 11 pi over 6 and 3 times the sine of 11 pi over 6, or root 3, 3 times root 3 over 2 and negative 3 over 2. For these two, you had to convert them. So you would do y over x. You should have gotten theta is pi over 6. And then x squared plus y squared gives you that r is 3. And the last one, you would have gotten -1. That means theta is 3 pi over 4. And your radius was 2. So those are your additional points. You only needed 2 of those.